Welcome back. Now let's talk about the composition of functions. So thinking about a root word in composition means composed of. And if I said something is composed of something, that would generally mean it's made up of something. So essentially this means F composed of g of x, right? So F with g of x plugged into it. So this notation, this is a largish, it's not a dot, it's an open circle, and it means composed of. So we read this as F composed of g of x, or F of g of x. So we can use any variables. It's not always just f and g, and it's not always in this order, f of g. We could have g of f or h of k. But for definition purposes, we're going to use f as our first function, and then g is going to be the interior function that goes into f. So we'll say here, given two functions, f of x and g of x, what by definition this composition means is f of g of x means f composed of, or f of g of x. Essentially, that second function is always going to plug into the first function. So if I had something that maybe said, hey, h of k of x, that would be the same as h of k of x. So the k function would be going into the h function. So when you see this symbol means composition, and it means whatever function comes second is going to go into the first. So we're going to have an inside and an outside function. You can see there, g is inside of f, k is inside of h. And then the other thing we need to talk about here is when we talk about domain. So we still have our same two domain rules. We know that the denominator is never allowed to equal 0, and if we have an even indexed square root radical, that the radicand, the expression under the root, must be positive, and we say greater than or equal to 0. So those two rules still apply. It's merely that when we are looking at the domain of a composition, we have to intersect. And when we intersect, we're going to look at the domain of the interior function, the function that went inside the other, and we're going to combine it with the domain of the result. So we have to look at the end result, but we also have to consider the function that went inside. All right, so before we get deeply into some domain examples, let's look at a couple different basic composition examples. The first one we're going to evaluate. So we're going to plug a number in to a composition function. In this example, we are asked to evaluate and determine what f composed of g of -3 is, given the f of x function is x squared minus x, and the g of x function is 2x plus 8. So I'm going to use some color here. We have f composed of g, and then we're going to plug in -3 for those x values. So by definition, f composed of g of -3, what does that mean? Well, that means f of g of -3. So that's just relating back to the definition we have right here on this first screen. This is what that notation means. Math is like a foreign language. You have to know what the notation means so that you can read it and you know how to apply your skills. So again, now that we're looking at this, by definition, you can see there's an interior here, function. Can I find g of -3? The answer is yes. We know what g of -3 is. This means we plug -3 into our g of x function. So g of -3 is 2 times that x value, which will be -3 plus 8. So I'll plug in -3, and we see that this inside g of -3, we get -6 plus 8. And -6 plus 8 is 2. So looking at what we have up above, we have f of g of -3, and we just determined that g of -3 represents 2. So if I asked you to evaluate this step, you'd say, well, that means I plug 2 into f. And my f function, f of 2, that's going to be x. I'm going to plug 2 in there, x squared minus x. So wherever there's an x, I plug in 2. That gives me 4 minus 2, which simplifies to 2. And that's just a coincidence here that we got 2 for both of these evaluations that we did. You're not always going to get the same number. You're not going to get 2 and then get 2 again. All right. So that's how we can evaluate this composition. Now, another way we could have done this problem would have been to first find out what f of g of x is. And by definition, that would be f composed of g of x. So essentially all I've done here was take that -3 out for my x value, and I'm just going to find that composition function. I'm just going to say, what does it look like if I take g and plug that into f? So that would be, we're essentially saying x squared minus x, because that's what my f function is. And what am I plugging into f? I am plugging in g of x. So now I'm kind of writing this out longer than you may wish to write it on your paper, but I'm really trying to help you see what I'm doing here. I am plugging g of x into f of x for each of these x values. That means I'm putting 2x plus 8, so 2x plus 8 in for that first x. I'll need to square it, minus, I'm going to subtract g of x, which is again 2x plus 8. So from here, I just need to simplify this. Simplifying this, when I FOIL this, 2x plus 8 times 2x plus 8, actually don't need that parenthesis, I have 4x squared plus twice that product, so plus 32x plus 64, and then we would have minus 2x and minus 8. Simplifying this, we have 4x squared plus 30x and 64, take away 8, is 56. So this represents f of g of x. And at this point, if we were asked to plug in -3, we could just plug that in for both of these values. And so f of g of -3, that's going to be 4 times -3 squared plus 30 times -3 plus 56. So I plugged in -3 wherever there was an x, and we're going to simplify, and we'll see that this will also give us 2. That's 4 times +9, which is going to give me a 36, plus 30 times -3, so that would actually be minus 90, and then we have plus 56. So minus 90 plus 56, and we can see that that simplifies to +2. So that's the alternate way you could have done that. Either way works. I just want you to find what works for you. I'm just trying to help you make sense of how to find these composition functions. So in the examples following this, everything we'll be doing, we'll be talking about the domain of those composition functions. We'll include that in our thought process. As always, please email me if you have any questions, comments, or concerns.